Right, strap yourselves in, because today we're going deep into superbug territory. And, you guys sent in a really fascinating mix of stuff this time.
Yeah.
Journal articles, news stories, even an excerpt from a book on herbal remedies.
Oh, wow.
So we're not just going to be, talking about the doom and gloom of antibiotic resistance, but we're also going to explore some of the promising new research on fighting back,
Right.
including some surprising solutions from the plant world.
Very cool.
So,
Yeah, it's a complex issue for sure. And, to really grasp it,
yeah.
I think it's important to understand the scope.
Huh.
The World Health Organization estimates that by 2050,
Right.
drug-resistant infections could cause 10 million deaths a year.
10 million.
Yeah.
That's a mind-blowing number.
Big.
It really puts the urgency of this whole thing into perspective.
Absolutely.
Like, wow.
And to give you a more concrete example,
Okay.
let's look at one particularly troublesome superbug
Right.
called VREfm. Yeah, vancomycin-resistant Enterococcus faecium.
Oh, okay.
This one's a real challenge because it's becoming resistant even to our last resort antibiotics,
Yeah.
like daptomycin.
So even the drugs that we thought we could count on as like a last line of defense,
Right.
they're becoming ineffective.
Yeah, it's concerning.
That is concerning.
And recent research published in Nature, actually,
Okay.
found a link between the use of a common antibiotic called rifaximin
Mm-hmm.
and this rise in daptomycin resistance in VREfm.
Hold on. So an antibiotic that's supposed to be helping us is actually contributing to the problem.
Well, it's complicated.
Yeah.
Rifaximin is often used to prevent complications in people with liver disease.
Right.
But it seems that its use, while beneficial in those cases,
Yeah.
is unintentionally creating an environment where VREfm strains that can also resist daptomycin
Oh, wow.
are more likely to thrive.
So they're like,
It's a delicate balance trying to solve one problem
Right.
while inadvertently contributing to another. And it really highlights the importance of antibiotic stewardship, using these antibiotics carefully
Yeah.
and only when absolutely necessary.
so the bacteria are basically evolving
Exactly. They're adapting.
to survive in the presence of these antibiotics.
Yeah, and to make matters worse.
Oh,
One of your sources highlighted the post-pandemic surge in beta-lactam antibiotic use, things like penicillins and cephalosporins.
right.
And while these drugs are essential in many cases,
Yeah.
this increased usage is likely adding fuel to the fire of antibiotic resistance.
It's like we're in an arms race with these bacteria,
It is
constantly trying to stay one step ahead.
a good way to put it.
So to understand how some of these resistance mechanisms actually work,
Yeah,
I guess we need to take a closer look at the bacteria's defenses.
exactly.
Right.
So imagine a bacterial cell as a fortress,
Oh, yeah.
and surrounding that fortress is a sturdy wall
Okay.
called the peptidoglycan layer.
Peptidoglycan.
Yeah, this layer is essential for the bacteria's survival.
Right.
It's like a strong mesh that holds the cell together.
So it's like their suit of armor.
Exactly, their suit of armor.
Okay.
Now, many antibiotics work by interfering with the bacteria's ability to build and maintain this peptidoglycan layer.
Right.
But as you might have guessed,
They're not just going to sit there and take it.
no, they're not.
Right.
Bacteria are constantly finding ways to reinforce their defenses.
They're upgrading their armor, so to speak.
Precisely they are.
And that's why research focused on the specifics of how this layer is made and maintained. That's so crucial.
It is. One of
Yeah.
your sources highlighted a recent study
Okay.
on an enzyme called MLTG.
An MLTG,
Yeah, found in Mycobacterium abscessus,
Mycobacterium abscessus.
which is known for being resistant to multiple antibiotics.
That sounds like a formidable opponent.
It is. It can cause serious lung infections.
Oh, wow.
Particularly in people with underlying health conditions.
Okay.
And understanding the structure of this MLTG enzyme could be key to developing new drugs that specifically target its role in building that peptidoglycan layer.
So disrupting this enzyme could make the bacteria more vulnerable
That's the hope.
to the antibiotics.
Yeah. And speaking of novel approaches,
Okay.
you won't believe this one.
What is it?
Researchers have engineered a single atom into a potent antibiotic.
A single atom.
A single atom.
I'm intrigued.
They combined manganese, a common element,
Right.
with something called nitrogen-doped graphene.
Okay.
This combination, which they call NGAMN,
NGA, man.
works by disrupting bacterial membranes.
Okay.
But here's the key.
Uh-huh.
It does this without even entering the cell.
Whoa! So it's like a siege weapon.
Yes.
Targeting the fortress walls from the outside.
It is. And what's even more promising is that it's also been shown to be safe for human cells.
Oh, wow.
Which is a major hurdle that a lot of new antibiotics struggle to overcome.
It sounds like a major breakthrough.
Yeah.
But before we get too carried away with all the high-tech solutions,
Sure.
I know we also have some promising research from the natural world to discuss, right?
Absolutely. Plants have been used for medicinal purposes for centuries.
Yeah.
And they're proving to be a treasure trove of potential antimicrobials.
Mm-hmm.
And it's not just folklore.
Yeah.
There's solid scientific research backing this up.
That's what I like to hear.
So we'll delve into some specific examples
Yep.
and discuss how these plant compounds can tackle superbugs.
I'm ready. Welcome back, everyone. Before the break, we were talking about the incredible potential of plants in combating superbugs.
Right.
And now we're going to dive into a specific herbal formula that was mentioned in the Lost Book of Herbal Remedies,
Okay.
which is one of the sources that you sent in.
Right.
And I have to admit, the idea of a formula specifically designed to target these superbugs,
Yeah.
it's pretty intriguing.
It is fascinating, and this formula isn't just a random mix of herbs.
Right.
It strategically combines plant-derived compounds,
Okay.
each with its own unique mechanism of action.
So it's a targeted approach using the power of nature
Exactly.
to combat these resistant bacteria.
Let's start with berberine,
Okay.
a plant alkaloid found in plants like golden seal and barberry.
Mm-hmm.
It's been used in traditional Chinese and Ayurvedic medicine for centuries.
Yeah.
And modern science is starting to validate some of those traditional uses.
I've heard of berberine. It's gained popularity as a supplement in recent years.
It has.
What makes it so effective against bacteria?
Well, research has shown that berberine can target DNA gyrase,
Okay.
an enzyme that is absolutely crucial for bacterial replication.
Mm-hmm.
By inhibiting this enzyme, berberine essentially throws a wrench into the bacteria's machinery,
Wow.
preventing them from reproducing.
So it's like disarming the enemy before they can even launch an attack.
That's a great way to put it.
And the formula doesn't stop there.
No, it doesn't.
It also includes curcumin,
Yes.
the compound that gives turmeric its vibrant yellow color.
Mm-hmm.
Curcumin seems to be everywhere these days.
It does.
Smoothies, lattes, even skincare products.
Yeah.
It's hailed as a health superstar.
And for good reason.
So what's relevant to our conversation here?
Well, in this context, it's curcumin's ability to disrupt bacterial cell membranes,
Okay.
weakening their defenses.
So it's like poking holes in their armor.
Exactly. Plus, it acts as an afflux pump inhibitor.
Afflux pumps.
You remember those?
Remind me what those are again.
They're essentially tiny pumps that bacteria use to expel substances,
Okay.
including antibiotics from their cells.
Right, right.
So curcumin can help prevent the bacteria from spitting out
Oh, wow.
the very compounds that we're using to fight them.
Oh, so it's like a double agent,
Yes.
weakening the enemy's defenses and preventing them from resisting our attacks.
Exactly. But the formula has even more tricks up its sleeve.
Okay, I'm listening.
It includes 6-gingerol,
This gingerol.
the compound that gives ginger its pungent taste.
Right.
Turns out this compound is also a potent antibacterial agent.
So the spice that we use to flavor our food could also be a weapon against superbugs.
It's incredible.
That's incredible.
Yeah.
I'm starting to see a pattern here.
Yeah.
These aren't like some exotic, hard-to-find ingredients.
Right.
They're things that we encounter in everyday life.
That's what's so exciting about this area of research.
Yeah.
The potential of nature is right there in our kitchens.
I love that.
So 6-gingerol works in a similar way to curcumin,
Okay.
disrupting bacterial membranes and possibly even enhancing the uptake of other antibiotics.
So it's like a tag team effort
Yes.
with these compounds working together to bring down those superbugs.
Yes, it is.
What else is in this powerful blend?
Another key player is anacardic acid found in cashew nutshells.
Okay.
Research has shown that it's remarkably effective against both MRSA and VREfm.
Hold on. The part of the cashew that we usually throw away
I know, right?
is a potent antibacterial agent.
It's amazing.
That's amazing. It makes you wonder how many other potential remedies
Right.
are hiding in plain sight.
It really does. Anacardic acid targets the synthesis of the bacterial cell membrane.
Okay.
It's like preventing them from building their armor in the first place.
Okay, so we've got berberine,
Yes.
curcumin 6-gingerol, and anacardic acid,
Mm-hmm.
all working together to disrupt bacterial replication,
Right.
weaken their defenses, and prevent them from building their protective layers.
Exactly.
Sounds like a pretty comprehensive attack plan.
It is, and to further enhance its effectiveness,
Okay.
the formula includes 2 more core ingredients
All right.
that work in a very specific way.
Okay.
Thymol and carvacrol, both phenolic compounds found in thyme and oregano,
Thyme and oregano.
have been shown to increase cell membrane permeability.
So they're essentially poking holes in the bacteria's armor,
Precisely.
making them more vulnerable.
Yes, this increased permeability allows the other compounds in the formula
Right.
to more effectively penetrate the bacterial cells and do their work.
It's like a well-coordinated military operation, with each component playing a specific role in defeating the enemy.
That's a great analogy.
But this is just an overview of the core ingredients.
It is.
Okay.
The formula also includes secondary ingredients like eugenol from clove oil allicin from garlic
Right.
and rosmarinic acid,
Wow.
all of which have documented antimicrobial properties and contribute to the overall effectiveness of the blend.
It's a truly multi-pronged attack hitting the bacteria from multiple angles.
It is.
It's fascinating how nature has provided us with all these tools to fight back against these superbugs.
It is remarkable. But before anyone rushes out to create their own super bug-fighting concoction,
Yeah.
we need to talk about safety.
Right. Safety first.
Absolutely. This formula, while promising,
Yeah.
is not a substitute for professional medical advice.
It's important to emphasize that.
Absolutely.
Yeah.
There are potential interactions with medications, potential side effects, and it's especially important for pregnant or breastfeeding women to consult with their doctor before using any herbal remedies.
So it's not as simple as just mixing up these ingredients and hoping for the best.
Right.
It's about approaching herbal medicine with knowledge and caution.
Exactly. Herbal medicine is powerful.
Right.
And it needs to be treated with respect. It's crucial to work with a qualified healthcare provider who can assess your individual needs, consider any potential risks, and guide you on the safe and effective use of these plant-based compounds.
That makes sense. It's about integrating these ancient remedies into modern healthcare practices responsibly.
Precisely. Now, we've covered a lot of ground today.
We have.
From the alarming statistics about superbugs to the fascinating ways that bacteria defend themselves to the incredible potential of both cutting-edge science and natural remedies.
It's been an incredible journey so far.
Yeah.
But I'm curious, is there more to this deep dive?
There is. We've talked about how scientists are developing new weapons against superbugs and how nature has provided us with an arsenal of plant-based defenses. But what about our own role in this battle? What can we as individuals do to help?
That's a great question. It's easy to feel powerless when facing a global challenge, like antibiotic resistance.
Yeah, it is.
But I have a feeling our choices matter more than we realize.
You're absolutely right. Individual choices have a ripple effect, especially when it comes to something like antibiotic resistance.
Yeah.
It's a collective problem that requires collective action.
Right.
And that starts with each one of us.
Okay, so we're back.
Yeah.
And ready to tackle that question we left you with.
Right.
What can we as individuals do to help combat the rise of superbugs?
Right.
It's easy to feel overwhelmed, you know, when we think about global issues like this.
It is.
But I'm hoping you can shed some light on how our everyday choices can actually make a difference.
Absolutely. While it's a global challenge, the solutions really do start at a personal level.
Okay.
And one of the most important things we can do is be mindful of how we use antibiotics.
You know, we've talked about this a bit throughout our deep dive.
Right.
But it's worth emphasizing.
Yeah.
Antibiotics are only effective against bacteria.
Exactly.
Not viruses.
Right.
So if you have a common cold or the flu, taking an antibiotic won't help at all.
It won't. And in those cases, antibiotics would be like trying to fix a leaky faucet with a hammer.
Okay.
The wrong tool for the job.
And what's worse is demanding antibiotics when they're not necessary.
Right.
Actually contributes to the development of resistant strains.
Yeah, it does.
So it's not just ineffective,
Yeah.
it makes the problem worse.
It does.
In the long run.
Exactly. It's like giving the bacteria a training course in how to outsmart our drugs.
Wow.
Another crucial point is finishing the entire course of antibiotics prescribed by your doctor.
Okay.
Even if you start feeling better before you've taken all the pills.
I'll admit I've been guilty of stopping early when I thought I was in the clear.
Yeah, a lot of people have.
Why is that so important?
Well, think of it like weeding a garden.
If you stop pulling weeds before you get all the roots, they'll just grow back stronger.
Right.
Similarly, stopping antibiotics early allows some of the bacteria to survive.
Yeah.
And those survivors are often the ones that are more resistant to the antibiotic.
Oh.
They then multiply.
Right.
potentially leading to a tougher infection down the road.
So even though we feel better, there could still be like stragglers lurking around ready to make a comeback.
Exactly.
What about our food choices?
Okay.
I've heard that the overuse of antibiotics in agriculture is a big part of the problem.
It is when animals are routinely given antibiotics.
Right.
It can lead to the development of resistant bacteria in their gut.
Right.
And those resistant bacteria can then end up in the meat and poultry we consume.
Okay, so opting for organic or sustainably raised meat and poultry is a way to support farmers who are using antibiotics responsibly.
It is look for labels like raised without antibiotics or antibiotic-free to make informed choices.
And what's fascinating is that our food choices can actually be part of the solution too.
You mean like eating a healthy diet?
Exactly. Remember those phenolic compounds we discussed earlier?
Yeah.
Those are found in fruits, vegetables, herbs, and spices.
Right.
Eating a diverse, plant-rich diet not only provides us with essential nutrients, but it also introduces these natural antimicrobial compounds into our system.
So we're essentially bolstering our internal defenses by eating the rainbow.
That's a great way to put it.
Love that.
It's a delicious way to support your well-being on multiple levels.
And it's not just about what we eat, but also the products we use.
Yes, antibacterial soaps and hand sanitizers,
Okay.
while convenient, can actually contribute to the problem.
Really? But aren't they supposed to be good for hygiene?
They do have their place, especially in healthcare settings, where preventing the spread of germs is critical, but overusing them, particularly those containing triclosan, can actually kill off the beneficial bacteria on our skin. Creating an environment where resistant strains can thrive.
So it's like using a weed killer that eliminates both the weeds and the flowers that we want to keep.
That's a great analogy.
We need to remember that our bodies are home to a complex ecosystem of bacteria called the microbiome, which plays a crucial role in our health.
It does.
Disrupting this delicate balance can have unintended consequences, making us more susceptible to infections.
Absolutely. It's incredible how interconnected all of this is.
It is.
From the way we use antibiotics to the food we eat, to the products we use, it all circles back to this delicate balance of bacteria in our environment and in our bodies.
And while the problem of antibiotic resistance is complex, it's empowering to remember that we're not just passive bystanders. We have agency.
We do.
Even small changes in our daily lives can contribute to the solution.
They can.
That's a reassuring thought.
Yeah.
So what are some of the most impactful changes we can make?
Well, it starts with awareness.
Okay.
Stay informed about antibiotic resistance. Ask your doctor questions about your treatment.
Right.
Be a conscious consumer support sustainable agriculture. Choose antibiotic-free options whenever possible. And embrace a plant-rich diet.
So we're essentially becoming stewards of our own health.
We are.
And the health of our planet.
Exactly. It's about understanding that our actions have consequences. And that by making informed choices, we can contribute to a healthier future for ourselves and for generations to come.
Well said. This has been an incredibly eye-opening deep dive.
It has.
We've learned so much about the complexities of antibiotic resistance, the fascinating world of bacterial defense mechanisms, and the remarkable potential of both cutting-edge science and nature's ancient wisdom.
It's been a pleasure exploring these sources with you.
Likewise.
And remember, the learning doesn't stop here.
It doesn't.
Keep asking questions, keep digging deeper, and keep making choices that support a healthier future for all of us.
Couldn't have said it better myself. Thanks for joining us on the deep dive.
My pleasure.
Until next time, keep exploring.